Good evening, everyone, and thank you to attending this fifth event of the St Albans Greener Together, the retrofit course. I'm Luigi Pintagood. I'm the head of architecture and design at University of Hertfordshire, and we are partnering with the St Albans City Council and District in this 2 years long project. We are at the end of this project, which was St Albans Greener Together. The idea is to fostering the transition to net zero while empowering people and groups to make difference through innovative behavior change campaign. So we believe in the importance of these conversations because we believe that these are able to enhance invisible impact on everyday life. And the combination of all these choices will help us to make a big impact on our life, our cities, and the built environment.
Welcome to the session. And we're very happy to have Duncan Baker-Brown on this session speaking about circular economy. And I don't think he needs an introduction, but I'll do it anyway. He has about 25 years of experience working in the industry and advocating for a systemic mindset change towards a circular economy and working towards projects that have actually practically delivered this on site. So it would be great to hear from him about what his opinion is on the subject, how the world is changing towards it, and what projects he has to offer. And with that, I'm also going to share my screen, requesting you all to give us a sort of an introduction about where you stand in this. So if you can see my screen and if you can scan the little QR code, and it'll open up a poll for you about asking you about your level of knowledge on implementing circular economy in the built environment. So if you go on the poll and let us know what level you stand at, that would be great. Okay. That's an interesting poll. Right, that's interesting. So if we have that ready and we know that Duncan's here to help us all deliver this practically to every one of us who have theoretical knowledge, I hand it over to Duncan to share your screen and start with the presentation.
Thank you, Dipti and Luigi, for hosting this event and inviting me. It's a real honor to be here tonight, and thank you for everybody that's taken the time out of their evening to be here. I've taught and researched and practiced around sustainable design and closed-loop systems for over 25 years now, and it's given me an opportunity to look at other people's work as well as my own. So for those architects out there in practice, we're always very busy, and having the opportunity to pause and think is very difficult. I'm going to share my screen now, and hopefully you can see my slides.
Yeah.
Right, good. Okay, you can see one slide, not the presenters when I take it.
Yes.
Yeah, good. Thank you. Okay. Yeah, circular economy and innovation. This is a personal take on it. And I'm initially going to talk about the sort of themes and issues that I think are influencing the way we think. So there you go. Cut to the chase. Yeah, I mean, what a world we live in. I mean, yeah, climate deniers in charge. And obviously it's all about tariffs today. And you got companies like BP saying they've been too green, and gone too far. So yeah, they're going to sort of follow the Trump mode and drill, baby, drill. And we're really sort of in this sort of situation where the grown-ups and the really old people are in charge, and what is the legacy we're handing over? And it is quite scary. From the point of view of resource extraction, which is something that concerns me, 10 years ago, the world, humans, I mean, extracted between 45 and 60 billion tons of raw materials every year from planet Earth. Move forward a decade to 2024, that's nearly up to 140 billion tons of stuff. Raw materials mined and harvested by humans every year. This is a recent news item from The Guardian saying that that's going to increase by 60% by 2060. A UN report says, I think it's easily going to do that because it's doubled in the last 10 years. So, you know, another 35 from now, I think it's easily going to double again, unless we do something about it. But yeah, that's 2025 so far. Nutty geopolitics, wars, and MAGA tariffs. And resource security being a thing of the past. We don't know how much things are going to cost, let alone whether we can get hold of them in the first place, or whether we want to because of the problems associated with extraction of materials and harvesting of stuff, the sort of collateral damage caused by doing this. So why us in the construction industry? Well, the construction industry consumes 50% of those billions of tons of stuff that's mined and harvested every year. Half of all the stuff is consumed by our sector across the world. And it's the environmental destruction associated with this process that is one of the main factors for generating the current mass extinction of species. Taking it back to the UK, in the UK, we consume 600 million tons of products a year. That generates a waste flow of about 200 million tons of waste a year. And the construction sector is 63% of that 200 million tons, 120 million tons of material goes to landfill and incineration, and it's from our sector, the construction sector. In addition to that, you can say that our industry is also about 45% of carbon emissions. Now, if you compare our waste flows, 63% of the total, compared with the EU, they're a lot lower. The construction sector in EU countries ranges from 35 to 45% of total waste. We are a lot more wasteful here for a number of reasons. So I would actually posit that perhaps hold on to what you've got and reuse it. Avoid those tariffs. So it's all about managing your existing resources and dramatically reducing the need to consume new raw materials. Close all those conventional mines. That's an aerial shot of a copper mine in Chile. It's very difficult to construct a building and not involve slaves. Reuse the previously manufactured, decouple from these wasteful, damaging, and morally obnoxious ways of being. So mine the Anthropocene or the Anthroposphere. Reuse the human-made layer of stuff. The Anthropocene is the current geological epoch that some people think we're in. A lot of geologists think we're still in the Holocene because it's only 10,000 years old or so. But the Anthropocene is the layer of human-made stuff that wraps the planet. It's the plastic on our oceans, landfill sites. It's the seats you're sitting on, the buildings you're in, etc., etc. Redevelop that, rework that, remanage that, and take the pressure off the natural world for producing all these raw materials all the time. Nurture natural resources and mine the Anthropocene. So the challenges of doing this is, well, the most obvious one is that we exist as a linear economy. We take stuff from the planet, we make it into things, and in a scary short amount of time, we throw it away. No other healthy system, natural system, organic system on the planet exists like that. A healthy planet and healthy biospheres are places where waste from one ecosystem is food for another. And we have to do that in the human world. Waste from one sector is a resource for another. So some good news. Well, we actually know what to do. And we're a really impactful industry in the construction sector. If you design a 10 meter by 10 meter concrete slab and you make it 50 millimeters thinner than normal, you'll save as much carbon as avoiding meat for a year. The other good news is that everybody's still asking, what is a circular economy? And here you can see I've got two circles. One's the biosphere, the natural organic stuff that grows, locks carbon when it grows. We process it and make it into things. We use those things. We might repair those things again and again. And as long as we don't add toxins to those timber things, for example, they can eventually go in the ground and become compost for new things to grow. However, that's only a minor part of what we produce as humans. And we're a lot more likely to producing stuff in what we might call the tech sphere. So that's materials, minerals, metals, whatever, that create our smartphones, our cars, our furniture, whatever it is, the televisions. These things need to be designed so they are material stores for future things, because these things can't be returned back into the earth. So think of current BMW cars have to be the source material for future BMW cars. That is the challenge for all designers. Current buildings are the material stores for future buildings. Now, more good news, like the Pritzker Prize, the biggest prize in architecture, international prize, was won a couple of years ago by David Chipperfield, well-known architect, saying retrofit, which is reuse and adapt the existing, is not only the right thing to do, it's the more interesting thing to do. And I agree, it is. Adapt the existing thing. We've got movements like the wonderful Don't Waste Buildings, campaigning to stop demolishing buildings in the UK. If you're a member of the RIBA and you're an architect, in about a year's time, climate literacy tests will be mandatory for all members. So climate literacy is an understanding of the climate situation, climate and ecological emergency, what that means, and then more specifically how in whatever trade and practice you're in this case architecture, what you can do to help to mitigate the situation. We also have the wonderful UK net zero carbon building standard. And I say wonderful because everyone's involved. There's some logos there, but there's twice as many logos. There's twice as many institutions involved. Academics are involved. All the industry institutions and the client-facing institutions and groups are involved in developing this. Now, what this is doing is creating a set of tools and rules by which the construction industry can go to government and say, we know what to do to stick to that 1.5 degrees climate change target. And we know how to spend our meager carbon budget. We have strategies for different building types in different sectors, and these are the benchmarks that we will follow. Now, what we're hoping to do with that is to have government and the UN at the COP take our industry seriously and then take advice from us. And one of the bits of advice I'll come to in a minute. The other good news is that DEFRA has a circular economy task force who at the moment are coming up with a draft circular economy plan for England. So I think if you've got the net zero carbon building task force and standard coming up with benchmarking whole life carbon, embodied carbon, as well as operational carbon, and the circular economy task force in effect majoring on the idea of reuse and designing buildings as material banks and designing out waste, these things are going to align. So perhaps we'll get one of these soon. So this is one of 3 bills that were presented to the Conservative Party when they were in government between 3 and 2 years ago. And these are 10-minute bills asking for a whole life carbon, embodied carbon bill. And that almost got passed with a Conservative government. So I'm hoping if this gets represented in the near to medium future, it will instigate what we've been looking for ages, which is what some people are calling Part Z. So that's the part of the building regulations that will benchmark and legislate for embodied carbon. And as soon as you're limiting embodied carbon in a construction project, you're limiting the option for demolition, throwing away and starting again, because the whole life carbon footprint is just too excessive. The other good news is that now it's up to hundreds of towns and cities in the UK have circular economy route maps, and they are impactful. In London, as part of the London plan, the circular economy route map has encourage startup companies who are in the world of doing deep surveys of existing buildings so clients understand the material resources of their buildings. If you have got a project over a certain size in London that you want planning approval for, and it involves the demolition of a building, London's going to make, the Mayor of London's going to make you deconstruct that building instead of demolish it, and look at ways that you can reuse those elements. The same for the Brighton and Hove circular economy route map as well, which I was involved in writing. Already impactful. And why I stress the fact that it's already impactful is because we don't have, these are only guidelines, it's not law. Now, what I use this slide and with the word hope on it is because I think cities provide us with hope. Most stuff manufactured and consumed flows into cities, whether that's water, food, clothes, or construction materials and products. But at the moment, these things flow in and they flow out, and these different flows don't talk to each other. And if you're trying to instigate circular economies, some of these linear flows in and out have to turn back onto themselves, turn into circles, perpetual circles, where there's no such thing as waste. Waste from one of these flows is a resource for a neighboring flow. So we need to consider our cities as material stores for the future. We need to become urban miners searching for new material sources to reduce the need for natural raw materials. And this is something we did years ago. Over 10 years ago, we built this. Well, I say we built it, over 360 students built it. It's the Brighton Waste House, and it's actually it says Europe's first permanent building made of 90% material discarded by others. But if you say it's a permanent public building and it performs to Passive House standards, it's a world first. It also can be seen as 55 tons of material other people didn't want. But we used that as a live project on campus at the University of Brighton with Brighton Metropolitan, Brighton Met students who are at the technical college nearby as well, learning construction skills, added to the architects and designers from our university. We built that house. And it's not a house, it's a two-story teaching facility. Now, since it was built, it's attracted other research funds. And Interreg is really interesting because Interreg funding across Europe requires partnership across borders with academics, but crucially SMEs. So it tends to be real world stuff. And what came out of this FCRBE project, which we finished a year ago, was a set of guides that anyone can look up online for free. And they're guides to how to identify how to deconstruct buildings from different eras and what you're likely to get in terms of materials. And this is the obvious one, bricks from buildings with lime mortar joints, sort of 19th century, early 20th century buildings. That's the easy stuff. But what about the 1960s buildings with a lot of concrete, steel and glass? So guides on what to look out for. We're putting together a directory of over 1,500 organizations dealing with the deconstruction of buildings instead of demolition, and crucially the reuse of those deconstructed elements. And that's across 6 countries who took part in this project. Now, what my main role was to curate a summer school, which was going to happen in Brighton in 2020, which was obviously the lockdown year. And we called it the School of Reconstruction. And originally it was going to be in August 2020. And the city of Brighton gave us this school, this secondary school to borrow for three weeks. And we invited students from across those 6 countries, engineering students and design and architecture students, to bid for the 80 places to take part in the summer school. And we got 80 students. And the people you can see there, they're the team leaders. They were working mainly in pairs. So we had this lovely situation where the city of Brighton were prepared to deconstruct a building that they'd previously put aside for demolition. So they were really helping us. I actually had to write a brief for a demolition company to deconstruct rather than demolish. So carefully take a building apart and then put those parts stack them up in the playground where our School of Reconstruction was. And then for 3 weeks, we had 10 teams of 8 students. They were going to reappraise this material. What was really interesting is that the city were then prepared to put the material out into their supply chain and see if anybody would go anywhere near this secondhand material. And that would have been amazing, but for COVID. So what you're looking at here is the event was then didn't happen, we then did it online a year later. And the reason I dwell on it is because a year later, obviously we lost the face-to-face aspect of it because we did it online. But what we did gain is 80 students, not just from across the 6 European countries. We had a different cohort of students mainly, and they came from across the world, from South America, North America, across Europe to China. And what we did with that is last year we published this book, and it's free to download online, and it's about 17 or 18 essays that come out of the people who took part in at School of Reconstruction. So different ideas of ways of teaching this idea of designing buildings as material stores for future buildings, and what's the language of reuse? If you're using secondhand materials in new buildings or adapting an existing building with secondhand materials, are we not in a new architecture epoch? Should our buildings not represent this epoch? So lots of different questions, really interesting. And some more good news. I put out another book last autumn. So this is about the doing of the circular economy. So this is the Reuse Atlas. I did the first edition in 2017 with the RIBA. And the first edition had about 26 case studies in it that were drawn from fashion, product design, and food industry, as well as architecture. And it was looking at, the book's divided into 4 main parts, and these different parts take you on a route towards proper closed loop systems and the circular economy. But the first step is the most basic one, which is recycling. Then you've got reuse, reduce, which means hardly do what you normally do as a designer, design the thing, but hardly use any material. How do you do that? Use a lot less than normal. And then the 4th section is dedicated to proper circular economy closed loop projects. Fast forward to last autumn, September 2024, and this is the new edition, which is actually physically a lot bigger book, but it's also got 40 case studies in it, 39 of which are from the construction industry. Now, to be involved in this book, I interviewed everybody who gave me a case study. And so it's quite a nice book to dip into because there's a lot of images, but also just quick sort of 500 words on each case study. And with everybody, I was asking, why were they pursuing this amazing project dealing with reuse or deconstruction and reuse, or the circular economy or recycling or whatever? How did they do it? What contracts did they use, construction contracts? And how did they get warranties on secondhand material? Because there's no point doing this unless we get the warranties and performance of new materials with these secondhand materials. And so that's why I found it particularly interesting, because it took a long time to write the 2nd edition, because I expected only to do another 25 case studies. Instead, we got 39, because I would interview someone and about project A, a hypothetical project, but then they'd say, well, that's a good project, but actually we got 2 others that are even better. So the good news is there's a lot more going on in this world of the circular economy. Is lots going on in the Netherlands and Germany and France, and now the UK is really interesting. So what I'm going to do now is take you through some case studies from the book, starting with the most straightforward stuff, recycling. I'm actually going to talk about one of our own projects. So we're based in Lewes, near Brighton, and we're on the South Downs. And this is a resource map that we do. We do one of these for all our projects. We look at the materials on the site, what it offers, and then what materials and resources nearby, 5 kilometer, 10 kilometer, 15, 20 kilometer radius. And that can be all sorts of things, waste materials from factories, from building sites. We actually locate planning approval sites, and to see if those sites have had their F10 certificates been issued, which means they've started up on site. We look at the idea of what is the project and what are the likely waste flows from those building sites, because remember that for every 5 or 6 houses we build in the UK, 1 house worth of waste goes to landfill and incineration. So there's lots of waste flows from our industry. There are also these other things going on. So unfortunately, we got this catastrophic ash dieback that's passed through Asia, Europe, and now passed through the UK. We have got tens of thousands of ash trees being chopped down at the moment because they've got this fungus infection, and they're being chipped and burned, which is a travesty, because all these organic things that grow, they lock carbon. The last thing you want to do is burn them because that releases the carbon. We had a project at Glyndebourne Opera House, And while we were doing the designing the project, they were chopping down 400 of these trees that were had ash dieback. And these trunks here were going to be, they were just getting on a lorry there to be sent to a power station to be chipped and burnt. We rescued them. We had a timber expert have a look at them, and he thought that they were reusable. So we got them sawn into planks and dried, and then we put them aside for the project. We then had another situation with a project on the South Downs where a house burnt down. The original project with Glyndebourne Opera House didn't happen because post-COVID, they didn't need the accommodation they thought they need pre-COVID. A lot of performance buildings, theatres and cinemas, etc., suffering for reduced numbers of people going to see them. So we had this timber, we had this ash dieback timber that we were able to sell to the client who was having to rebuild this burnt out house. Now this house is at the highest point of the South Downs, up a tight, narrow path, sort of, winding farm track. That was one of the reasons it burnt down, by the way, because the fire brigade couldn't get to it. So we've got a site here where we didn't want to take anything off site because it was too difficult to do that. So what you're looking at are the material sources for the new house on site. So we reused the brickwork, the blockwork, and the concrete. The South Downs National Park wouldn't let us, and well, not that we wanted to either, but they wouldn't let us rebuild the bungalow that was there before. And by the way, it is a bungalow, but it was an 8-bedroom bungalow. It's massive. So they asked us to cut and fill the new building into the south-facing slope of the downs where the bungalow had sat. And so from the point of view of people walking past, what they saw was what looked like a quarry, a lot of chalk being dug out. But I can say what you're looking at there on the left is the chalk being reprocessed. So it's been ground down into smaller elements so we could use it to create plaster for the new house. We did a similar thing with the concrete and some of the bricks here, but mainly concrete here and blockwork that we ground down. So we made the windowsills and coping stones for the new house out of the waste material on site. And here's a detail of a windowsill sitting on top of bricks, which are from Chailey, which are from 4 miles away from the site. And the sort of fat mortar joints you can see there are lime mortar. So one day these bricks can be reused, those windowsills can be reused. We looked at reusing the burnt bricks on site. Because they were burnt, we couldn't use them structurally. But what you're looking at here is a sample that we did where we were going to use these bricks for the floor finish. And that's a rough sample. But we even had I should have the photograph really because it's more impressive in a way. We smoothed off the face of these bricks so it became a smooth floor finish. So the idea was to use some of those bricks on the floors. And here we're looking at samples for plaster for the walls and ceilings in the new building made out of chalk from the hill that we cut out to allow the new partially subterranean house. But also we used clay from the bottom of the hill, which is this slightly off-white, beautiful stuff. So we mixed the clay and the chalk together and we made plaster for the interiors of the building. And here you get a glimpse of what we did with the ash dieback. We turned it into glue laminated trusses and beams and rafters for the new building. And here it is emerging. So the timber cladding for the barn-like elements is actually, in this case here, it's sweet chestnut. And we used sweet chestnut from local coppices. Sweet chestnut is almost like a miracle material. The Romans brought it over. The timber is really durable. And a colleague of ours did research about 30 years ago that proves that quick growing sweet chestnut that was only 25 to 30 years old was more durable than 100-year-old oak. So leave the oak trees alone, let them support 2,500 species and rework the working coppice woodlands that the Romans originally brought over because they knew how useful this timber was. And we then developed it more in the Middle Ages through right up to the 1980s. And it's only been the last 3 or 4 decades that it hasn't been used so much. Now, what's amazing about this is if you rework those coppice woodlands, and start getting a crop of timber off those woodlands in a 25, 30-year cycle, you get a greater level of biodiversity than if you leave those woodlands alone. So I would say that that is an example of regenerative design. If you don't know what coppicing is, if you don't know what coppicing is, it's where you cut the tree down to just above the ground and the roots live. And when the sprouts come up again, you don't just get one trunk, you might get a cluster of 8 or 9 sprouts and poles, and then they're what grow on a sort of 25-year cycle. It's a super deep carbon sink because the roots are established. They can be hundreds of years old. And so as soon as the growing starts immediately after you cut the previous growth back, it's a carbon sink. Whereas if you clear fell, say, an oak woodland or softwood pine woodland, you then plant new saplings, and it's not for 50 or 75 years that woodland becomes a carbon sink until they've established. But coppices are amazing. And this is the building set in its on site, and that is where the bungalow had been. The other thing that was quite controversial is you couldn't see the bungalow before because there were 75 trees in the way of where the house is now. And South Downs National Park asked us to chop those down because they weren't indigenous. And from their point of view, the South Downs, this is a south-facing slope. South-facing slopes aren't wooded. So the landscape people at the South Downs even wanted the trees behind the house all chopped down. One of the reasons is that they were all planted at the same time. So in effect, they were all going to die within 5 or 10 years of each other. So, but luckily we stopped them making us chop those down. But it could look like quite a controversial project because it looked like we're setting up a quarry on site. But we ended up not exporting any waste material off site or any chalk off site. And here you can see the ceiling structure is ash dieback. The walls are chalk and clay from site. And the screen on the floor is the aggregates are from the old bungalow. And here, timber, ash dieback. Some of the bricks in the floor we were able to use from site. And yeah, basically brick, lime, clay, chalk, and ash dieback. And here's more ash dieback. We had a 3-story staircase made completely out of ash dieback. This is a waste material. This is why I'm showing it to you. So this material is currently overlooked and burnt. So step 2 in the book is about reusing stuff. Now, one of the best people at doing this are Rota Deconstruction, based in Brussels. These photographs should be read from the top left to the bottom right. They unpack buildings and redistribute the second-hand components of buildings across Europe. So this is a bank building being deconstructed carefully. You can see it ends up in packing cases. They're working on this building. This is a book you can build. You can, sorry, did someone ask a question?
Yes, I can do. I think, sorry to interrupt.
You go, Dipti.
Okay, yeah. So the question is, was it the client who helped bring in and believe in this approach for his house?
No.
I think it's about who drove the decision.
No, no, we brought that to the project. So yeah, that was quite interesting. Is that we, in effect, I guess what we did is convince the client that it was a cost-effective, viable thing to do. And the building contractors who we work with have done similar projects with us on other projects. So we were able to prove that it would be cost neutral. And because we're stuck on the top of the hill with poor access, it is, I mean, on any job, if you take waste material off a site, you pay landfill tax and you pay for taking waste material off a site and getting it burnt or sent to landfill. It's mainly burnt where we are. So there's a cost associated with throwing stuff away legally anyway. So to leave it all on site and reprocess it on site, it can be a cost-effective way of doing it. It's just not a normal way of doing it, or it's not the way we've done it for 100 years. So a lot of what we're talking about is remembering how things used to be built. They're quite sort of they're sort of we're now called like conservation type ways of building with vernacular historic materials, building out of the landscape in the case of the chalk and the lime. With regard to the plaster, it was interesting because there was a point when the contractors slightly lost their nerve and they didn't want to do it, even though they'd done it before for us. And it was literally a case of the sort of chemical profile of the plaster they were putting on the walls was a normal clay plaster. But normally that clay plaster comes in branded bags. And this clay plaster came from the site. So even though it was mixed to British standards, had the sort of chemical DNA that would match the stuff that came out of a factory from the West Country, it was just the fact that it was done like that that made the contractors lose their nerve. But it's been perfectly fine. And it's the way every historic building in the UK that has lath and plaster or clay or lime plasters would have had their plaster made. So yeah, so it's a bit of loss of nerve sometimes. But what we've got to guarantee is that the building is done to British standards, codes of practice, and building regulations, and that's what we do. So it gets signed off. It's got the performance warranties of a normal building. Can I move on now? I'm going to.
That's a follow-up, I think.
Yeah. Okay, so this is Rotors. They have a warehouse where they sell all sorts of things, but material from that building, which was is the World Trade Center in Brussels, it was a sort of adaptive retrofit project. So in some elements, they were reducing the width or the height of the existing towers, as you can see. But you can see the materials being stacked up, and it ended up being redistributed here in the Rotors shop on the right and their yard on the left. There's only a small percentage of the sort of accommodation that they have. They also have a digital platform as well where you can buy secondhand materials. This is another project by sort of reuse pioneers, super use. And what I like about this is this lovely storyboard, very simply drawn, and you read it from the top left to the bottom right. And it's the story of a derelict school building on an island in Rotterdam that's been measured, deconstructed, and reassembled in a different way. So you make your new building out of the old building. And so here's the partially deconstructed old school building. Now, what they did is a 3D survey of that building so they could make a 3D model of the component parts of the building, and then they could play around with those parts. And the new building is still a school building again, but it's sort of a dance academy, and they work with some of the kids that would be using the school and let them play around with these elements. So it's a bit like a game. And of course, they put the elements back together a bit differently. And then Superuse learned from that, and they did the real thing a bit different. So whoops, there it is. That's the new building made out of the old building. And it's deliberately designed so it looks like they've imported new insulated sandwich panels from industrial buildings. Looks a bit unfinished there, but the idea that you could make something new out of what you had in the first place. Talking of which, this is the Entopia building at the Cambridge Institute for Sustainable Leadership. And this is the building as it originally was, which was actually a telephone exchange. People didn't live in this building. It was full of equipment. So the challenge was making the building habitable because they wanted it for this new center at the University of Cambridge. And so a lot of attention was given to the window design to let natural light in. They had to add insulation to the building, but they did that with cork and lime and clay materials. That was all good. That's not why I was interested in the project, though. They even used secondhand steel on the roof. That steel frame is secondhand, not recycled, but secondhand. There's a big difference. And that steel frame is used to house the renewable technologies, the PV panels. But it's actually the least remarkable of the slides that I'm really interested in. It's this one. The furniture, kitchen, the light fittings and the MEP is all secondhand. And that's unusual. So one of the reasons I would say that the UK construction industry is more wasteful than others is that we do build a lot of tall commercial buildings in our financial districts like the City of London or in Manchester or Glasgow. And these buildings, they have these sacrificial interiors that are called Cat A or Cat B fit outs. And what landlords will do is in brand new buildings, put a temporary, or sorry, not even temporary, they'll fit out the floors of the building so people who want to or maybe thinking they're wanting to lease a number of floors of the building, will see it fitted out. But then, of course, if they say, I'll take 3 or 4 of these floors or all of the building, they then want it branded with their own company brand. So the first thing that happens is all the stuff you're looking at gets torn down. And honestly, this stuff is installed with an expected lifespan of 3 months, and then it's thrown away. Well, not in this case. So the contractors who worked on the Entopia building in Cambridge were also working on taking out a Cat A fit out from a building in London, and that fit out was reused here. And what you get is, what's interesting in this is that the MEP, the mechanical ventilation heat recovery, plus the light fittings, has all got warranties, and that's on second-hand stuff. And just one last thing on those tall commercial buildings. Sometimes, they'll only every 20 years they'll be torn down and rebuilt in a new style. So that's another reason why there's a huge amount of waste. But in those 20 years of life, they would have had their Cat A, Cat B fit outs on and off, as well as being fitted out at a regular 5-year cycle anyway. So the waste flow of these buildings is enormous. This is a company called Cleveland Steel. And Cleveland Steel based in Yorkshire, and they needed a new large light industrial building to house what they do. And instead of buying a new one, and I mean, it's 12,000 square meters of new building. It's a big building. But instead of buying a new one, they found an old one, an existing one in Dublin. And because it had a BIM model, this is a 3D image from the BIM model, they thought, right, we know what it's made of, we know how it's made and what it is. And so they bought the building, deconstructed it, and reassembled it on site in Yorkshire. And it wasn't quite the same as the BIM model. They had to introduce some new steel elements. It wasn't quite working for some reason, and they had to faff around with it quite a bit. So it wasn't straightforward. But to cut to the chase, they saved £969,000 on a £5 million project, which is a big percentage. It's 20% of the cost of the build of a new one. So the point is, by going through an exercise which is unusual, finding an existing building that was due for demolition, deconstructing it and exporting it to where it needs to be and rebuilding it, saved them a lot of money. And this is what they do, by the way. For the last 40 years, they've been receiving and procuring steel tube. And this is the material, it's excess from the oil industry, from pipelines, and what it's normally used for is sports stadiums. So the London Stadium, that was the Olympic Stadium in 2012, the tubular steel structure there was from this source. And Spurs' new stadium, etc., etc. Now, the reason why that's quite interesting is because what Cleveland Steel are used to doing is giving warranties to second-hand steel. Fast forward to now, and they're not just working with tubular steel, they're working with deconstructed steel frames from buildings and giving that steel framework a warranty. So they've become a case study for giving design performance warranties to second-hand steel, so other people will follow. And this is what we need to establish a proper circular economy industry, is the precedence of different elements of a building getting the warranties that it requires. So here we got steel frames.
Duncan, we have a question about, I think, the previous buildings, Cleveland, till the Cleveland one. Was the transport from Ireland also taken into account in terms of cost and CO2?
Yes. Yeah, so it was shipped over the Irish Sea and then driven on the motorway to Yorkshire. Yeah.
Thank you.
But well done for bringing it up as an issue. So you never get away with a zero carbon project, really. I mean, I mentioned earlier the sort of net zero carbon building standard. One of the things we talked about, because I was on the governance board for the net zero carbon building standard, and we wanted to ditch the net word. And I was at a conference yesterday, and we had the CEO of the World Building Council, Green Building Council there. And I've been to the last couple of COPs representing the RIBA, And what's interesting there is that the World Green Building Council and other people talk about near zero, not net zero. And I think it's really important to talk about near zero. So get to near to zero as possible, but you've just got to be honest about it. In this case, of course, if the building is in Ireland, there's going to be some sea miles and road miles attached to it. So, but it's got to be better to be reusing a building than to be manufacturing new steel with that carbon footprint for your building. That's my point of view. This group are called of architects and designers are based in Copenhagen in Denmark, and it looks like Lendiger, but they're actually Leniger. And what they've done here is the diagram shows an existing dilapidated school due for demolition on the left-hand side, and the materials from that building being deconstructed created the new school. And here we go. These are drawings. I'm quite interested in how architects are drawing for deconstruction and reuse. And this is a new classroom made out of elements of the old building, including the image on the right, which shows how existing trusses have to be put at closer centers because new loadings are increased compared with 100 years ago. And so they're using them a lot closer centers, so they work structurally. But they're also having to introduce new steel elements to make them work as well. But it's quite a nice drawing that shows what's existing and what's new. And this is the collection of buildings ranging from the main building at the background there, which is from the early 20th century right through to the 1990s. These are the buildings being deconstructed. This is the beginnings of the sort of the wide and varied material sources that come off this one collection of school buildings. And then that's the new school made out of the old school. Now, I'm not commenting on the aesthetics of it or whatever, but just as an idea that even that collection of buildings from different eras was able to be deconstructed to a greater or lesser extent to create this new building. So I'm going to pause here because I want to ask you this question. What do you believe are the biggest challenges in specifying second-hand building materials? And I'll stop sharing my screen now.
So if you could all scan the code again, if you have it open, then the question will pop up on your screen. So based on what you think and you believe are the biggest challenges, put in your words into it, and you'll see a word cloud pop up. That's a lot of words popping up. Client and warranties seem to be the biggest. Cost, transparency, timeline, contractor. That's interesting. What do you have to say, Duncan?
I think these are wise words. Yeah, I mean, warranty is the big deal, and that's why it was the question I asked everybody that I interviewed is how did you get the warranties? Where you need performance warranties, how did it happen? So that was always interesting. Cost, yeah, I mean, I think in some cases, I would say if it starts costing more, don't do it. But also clients, yeah, I mean, I think it depends. I mean, I think what we've got to do is legislate for it to create the environment where deconstruction of a building is the more cost-effective thing to do rather than demolition and throw away. So I think if you create the industry, then what will happen is you'll get the physical, and I'm going to talk about it in a minute, the physical and digital infrastructure to support an industry of deconstruction and the distribution of secondhand materials with warranties. Once you've got that and you've got the then you're in a world where it doesn't cost more to do this and the materials are ready available. And we all know if we work on heritage buildings, we use secondhand roof tiles, and slates and bricks whenever we can, and clients don't question that, they like it. So that, you know, we sort of do it already. But yeah, I think clients can be the big thing because they don't want you to do something differently to what's been done before. Especially, I'm talking about commercial clients at a bigger scale. However, I would actually say that local authorities are very well informed around this issue, I find. And so, yeah, I think if we're in a world where there's a circular economy plan for England and local authorities have circular economy route maps, and we're benchmarking embodied carbon as well as operational carbon, it's just going to be the way of doing things. So yeah, we've got to convince clients, we've got to make sure it's cost neutral, and we've got to make sure that I mean, I had a question yesterday, which was, do you think we're over, you know, there's too much legislation and regulation for secondhand materials? Yeah, and I'm like, well, no, I don't. You know, we've got to make sure that buildings made out of secondhand stuff perform and have the same levels of standards of construction as brand new buildings. We can't say that secondhand stuff means second rate. We're on a hiding to nothing there, and you know that's awful. Someone question whether I'm muted or not.
No, yeah, I think they didn't have the right audio or something like that.
Oh, okay.
I think there was a question that asked earlier about the cost bit.
Cost consultants, yeah.
Yeah.
Yeah, cost consultants, that's a difficult job. I mean, what I mean to, and I really mean saying I mean, because at the moment, I think quantity surveyors tend to use SPONs and other sources of costs, which are basically reporting on how much did that theatre in the southeast of England or the southwest of England cost to build, and that's where they get their prices from. And those costs for constructing buildings at the moment allow for 10 to 15% of wastage on site. So your clients are paying for materials that get thrown away unused. And like I said, for every five or six houses worth of buildings we're throwing away about 20% of that material arriving on site. So my point of view is that we're very wasteful at the moment, and actually bills of quantities need to be interrogated. And surely if you're in the world of designing out waste on site, which I haven't talked about very much yet, but that's an ambition, designing out that 20% of waste on site and using secondhand materials, you should be in the world of saving money. And that's why I use the Cleveland steel example, and there'll be others in a minute. You save money by using secondhand materials or by adapting what you already have. Cost consultants understanding how to price for that is a challenge. And because they tend to make their new prices based out of precedent studies, looking at things that have already been built, that's why I want to shine a light on more and more precedents so they can draw off those experiences and that they can begin to feed into their cost plans. Questions? Shall I carry on with the presentation?
Yeah.
Can you just tell me if you can see it?
Yes.
Good, that was the question. Oh. Right, so I'm actually going to talk about the digital and physical infrastructure that I think we need. Some of it's out there already, but we don't know about it. So what I'm showing you now is a 3D digital map of the greater metropolitan district of Amsterdam. And this was prepared by a consultancy called Metabolic. And at the beginning of the talk, I was discussing this idea of materials and stuff flowing in and out of cities. Metabolic are a consultancy that map that. Now, that includes mapping the sort of DNA of the built environment. And these spikes are the amount of materials on a particular site, and they're color coded to represent the type of material. So that's a sort of high level resource map of Amsterdam from the point of view of the construction sector. This is a sort of the opposite end of it. This is a sort of micro granular survey of one element of a large hospital complex in Amsterdam that's due for demolition. And this is research work from about 5 years ago by someone called Dr. Elmer Demizovic. And what you're looking at there is a color-coded model that comes out of a 3D survey that's you can plug into Revit. And the color coding doesn't talk about the material type, it talks about the quality of the material. So the ability of it to be reused, and as you can see, as a sort of color coding on the left-hand image of green down to red, the ability of the element to be reused or not. And there's the color-coded 3D survey there. So it's looking at the resource potential of this building. And Elmer was telling me recently that there's in this hospital complex, they've measured and understood and surveyed the type and quantity and quality of the steel frame. And that steel frame is currently for sale. And if anybody buys that steel frame, this building will be deconstructed. If there's no sale for the steel frame, secondhand steel frame, the building will be demolished as normal. So I do know of buildings across London that are being surveyed at the moment for their steel, hundreds of them, and new buildings being designed anticipating the deconstruction of those host buildings. Now, this is exactly the same model as Elmer Demizovic, but this is like last year, and this is by a company called Lagermat, who are a demolition company. They're doing exactly the same as Elmer. They're trying to ascertain the resource potential from this existing building. And if they can find a market for it, you can see that window and panel system being digitally deconstructed for its elements. If they can find a market for those elements, this building will be carefully deconstructed rather than demolished. And this is an organization, a network called Insert, which again, it's in the Netherlands. There's a lot of this stuff in the Netherlands because they've got ambitious circular economy plan like we will have. They've had for the last 5 years or so, a nationwide circular economy plan, but they've also got ambitious zero waste targets. And because of those targets, people are becoming creative. But Insert is a national network of demolition companies rebranding themselves as deconstruction companies, and they sort of share resources, and you go on their website and you can find secondhand materials. Similar stuff is happening in the UK. So this is in the UK. And so check this out. This is a sort of a website of circular economy initiatives happening in the UK. Now, remember, we're on this sort of 4-step route towards the circular economy. So here we are on step 3 out of 4. And what I'm showing you has been are these case studies from the Reuse Atlas. So what I'm going to talk about now is reduce. Obviously, the most obvious thing to do in the world of reduce in the construction sector is to retrofit, to rework the existing built environment without knocking it down, deconstructing it, or whatever. And creative reuse and adaptive reuse, I think, is a huge creative opportunity for us all. And a lot of it is looking less creative, but it's still really vital. So obviously, we've had a cost of living crisis where our energy bills have gone through the roof. Our buildings are unaffordable to occupy, whether they're public houses, leisure facilities, or our own homes. And our energy bills have been capped, but really the government are paying the fossil fuel procurers the additional money. So at the moment, the money that could go into improving the thermal performance of our housing stock, which is notoriously bad, has gone to line the pockets of those fossil fuel procurers. It's just absolutely mad. But before all that happened, we were commissioned, my practice and at the University of Brighton, a sort of joint venture with 10 other consultancies, we were commissioned to create a retrofit route map for 55,000 social homes across 7 local authorities running from Crawley down to Brighton and a couple of local authorities east and west of that. And what they found out was that across those 7 local authorities, there were only 8 house types, ranging from semi-detached bungalows to blocks of flats. And we undertook a deep survey, and I won't go into all the different ways we surveyed it, but we were looking at how those buildings really performed, what their energy and water bills really were, and where the buildings really leaked energy and heat, etc. And we were then tasked with this idea of proposing solutions to get existing buildings up to EPC C, or then LETI best practice and LETI exemplar. And LETI at the time was the London Energy Transformation Initiative, and they have, in a very positive way, defined a sort of whole life carbon plan for the construction industry. Their climate emergency design guide from 2020 was really impactful. It had over 1,000 people taking part in the creation of this document. And one of the things they've brought out since is a guide to retrofit. So they came up with this idea of their best practice and exemplar level. So this, I mean, if you're doing a LETI exemplar retrofit project, it's basically a sort of passive house standard retrofit. So we were looking at the cost implications of that. Unfortunately, what happened after the 2-year study, and here we are with the larger buildings as well, after working on it for 18 months, the cost of living crisis really kicked in, and social landlords weren't allowed to add increases to the rent, of course, because people were paying enough for the energy. So they didn't have the budget they thought to do this. So this project's been parked. And at the moment, we really don't know how we're going to afford to retrofit our buildings. So we really need creative responses to this, a sort of financial creative response, as well as the sort of physical architectural response. But I'd also say this is another project of ours. The London Borough of Newham gave us 4 totally different projects. So that's a sort of top left, Ivy House is a building converted into a cafe. Top right, Stock Street is a 5-story Victorian warehouse converted into serviced office space. Tate Institute on the bottom left was an old theatre and community building, and Wilthorne is a sports centre. And we were tasked with coming up with retrofit strategies for these totally different buildings from totally different eras. And why I'm showing you this is because local authorities are really keen on this. But what we've got to remember is that retrofit has to be a lot more than just external wall insulation and solar panels. And, you know, this is the disaster that was the Grenfell Tower disaster. You know, that was a retrofit project at the end of the day. So we've got to remember that retrofit has to be a lot more than external wall insulation and solar panels. I want to look at a positive response to the retrofit challenge here, a creative response. So the tower on the left was going to be demolished. It was the flats were almost unoccupiable. There's no insulation, so they're really cold in the winter, really hot in the summer. And the city of Paris, the mayor put aside 34 million euros to demolish this tower and then rebuild it. And there you can see on the right, it's rebuilt. But Lacaton and Vassal, who are Paris-based architects, they went to the mayor and said, we can give you your new tower for 2/3 the price. So here it is, retrofit costing a lot less than new build. And all they did, this diagram shows it, there's the existing, a single flat there, notional flat there on the left-hand side with the existing glazing and concrete panelled wall. They literally just took off the old panelled wall and bolted on a new, this is what the right-hand side image is showing, a new, what we would call winter garden, which is a steel frame little glass house really, with sliding glazed panels, double glazed, next to the edge of the original flat, then a 2-meter extension, and then another set of glazed panels. Notice they've got blinds on the inside to reduce glare, and they've got a balcony which will shade you from excessive sun in the summer. And here you go, here are the winter gardens being applied to the old building. And what's quite exciting here, and what's brilliant, one of the benefits of retrofit is that you don't destroy communities. So people lived in this block of flats while this work was being done. They had to stay out of their flat for a day while they bolted on one of these winter gardens. But apart from that, they were on site. And there's a book written about this project, and the tenants are complaining about the dust and noise of the project. But you know what? At the end of the day, they weren't disbanded. Communities that the communities in these towns, when they get demolished, those communities don't reform elsewhere. They get dispersed and they never come together again. So what's really nice is that one of the added benefits of this is the community are intact. But this is the main benefit. That's the same flat before and after. So before you had cold winters, damp winters, and with condensation, you've got overheating in the summer. You've got lights on during the day because there's hardly any natural light. There's no ventilation. And you get all of that with this winter garden. And I haven't mentioned it, but you get an extra 16 square meters of floor area for nothing. And your utility bills have just reduced by 50%. Now, the architect behind this, Anne Lacaton, when I interviewed her, she said, please don't call us a green architect or sustainable architect. This is just sensible design. Now, I was talking about those commercial buildings in London that get torn down after 19 years, after being fitted out 5 times, etc., etc. And this is one of those. This is number 1 Triton Square that was 19 years old, and British Land and Lend-Lease were thinking about demolishing it. But the architects, which were Arup Associates, convinced them, they were the original architects, to extend the building by 3 or 4 stories, but to keep the existing building, but also crucially, and this is why it's in the book, they deconstructed 9 stories of the original curtain walling, sent it to a car park in Watford, cleaned up that curtain walling, upgraded it, and reassembled it on site as the new curtain walling. So the curtain walling system on the brand new building, as it were, is actually 20 years old now. Crucially, it got a warranty from the original supplier. So there you go, second-hand curtain wall system on a building with upgraded performance and the full warranty. And then there's a list here, because you didn't demolish it. You've saved 33,500 tons of concrete kept in situ, 1,843 tons of steel reused, etc., etc. 40,000 tons of carbon saved, equivalent to the annual energy consumption of 10,000 homes just on one building. And there's your precedent for someone in the supply chain willing to give a warranty on a facade system. So this is the home run now. Step 4, the circular economy. So this is where new buildings and material banks for future buildings. And this image on the left is from the year 2000, actually. It's the Swiss Soundbox, which was a pavilion in the Hanover Expo. And this is just the entrance to the pavilion. The pavilion was really big. It was sort of sat on a half-acre site. It was massive. And it was beautiful. And all it was actually was a stack of timber. And you got the structural stability out of the timber stacks by compressing them with these steel springs, which is great. Now, what happens with these pavilions is 1 or 2 of them at the end of their expos, they get bought up by billionaires and put in their gardens or whatever. Some of them get put in storage, but eventually they mainly get thrown away. The amazing thing about Peter Zumthor's Swiss Soundbox is at the end of its life, they took the springs off, and then you've got stacks of timber that went and supplied hundreds of building sites with timber. That is a circular economy principle, big tick. Here's another one. This is War Thistleton's number 6 Orstman Road. Now, War Thistleton are a practice that are known from in the early noughties and the 2010s. They were nightclub architects. And then Andrew War of War Thistleton, he said to me he had his black urinal moment. And that was the point where he realized he was at 2 o'clock in the morning on a Saturday. He was online trying to find a black urinal for a nightclub he was designing. And he just thought, what am I doing? So he virtually closed the practice down. And they thought, how can we have some sort of positive benefit on people and the environment? So they're now the sort of, in the UK, the leaders in CLT construction in buildings. Now this building is using CLT, but not just CLT. So you can see the steel frame here is bolted together. So one day it can be unbolted and reused, no welding. And then you've got CLT, which in my opinion, what CLT does best is providing the decks. It's very efficient in terms of the use of timber to provide the decks. Now, what was nice about this project, or sorry, not nice, there was a challenge. The response was nice, but the challenge was that halfway through the construction process on site, a new client took over with new requirements. And one of those new requirements was an extra staircase. Now, most buildings that have certainly been built at the moment, probably the ones you can see on the horizon in this image, but a lot of buildings where I'm in Brighton, even 2 or 3 story buildings, they're made out of concrete for some reason. A lot more concrete's poured at the moment. You have concrete floors, concrete walls and structure. And normally a building like this, which is a sort of 7-story office building, the floor decks would have been in situ cast reinforced concrete, which would have been a real pain because, like I said, the new client wanted a second staircase. So what Thistleton did is they just cut a hole in the CLT floor, which they could do because it was CLT timber, and they used that CLT to make the staircase. So nothing was thrown away, a completely adaptable system. And hurrah, you got your staircase out of the hole created by the stairwell. And here you can see it installed. Now, it's not their prettiest building. That's the black and white building, in my opinion. There's another one, check it out. It is beautiful. But this one's really nice because, from my point of view, because it is a material bank for future buildings. And these panels can be easily removed and the whole building can be disassembled. So can this one, which actually looks remarkably similar, even though this one's in Amsterdam. So CPZ are a firm of architects and builders and property owners. They do all of it. And they enter the competition to design a temporary court building in Amsterdam, which is quite a large building. This is just the end elevation. Excuse me. Anyway, so they entered the competition to design this temporary courthouse while the main 19th century courthouse was having extensive renovation. When they entered the competition, one of the competition requirements was to speculate on how the building would be reused one day after its 7-year life. And rather bravely, CPZ said, well, that's daft. We don't know what's happening next week in the way the world is at the moment, let alone 7 years' time. So what we'll do is make sure that our building is really adaptable and flexible and deconstructible. So they did build drawings of their buildings in this sort of layers. So you've got the top layer. I'm looking at the left-hand image now. So you've got the internal fit-out elements. So this is obviously from a Revit BIM model. And then the middle image shows the external skin of the building, and the bottom image shows the frame. And then interestingly on the on the right, you've got the 1 to 5 details that show how all these things come together without sticking. And that is the big point. Do not stick buildings together, bolt them together, screw them together. Now, I asked the project architect for CPZ if they could send me deconstruction photographs, because this building was deconstructed a year ago. It's been reassembled on campus at a university, and it's got a totally new life because the courthouse, 19th century courthouse, was finished being renovated, is open again. But when he sent me loads of deconstruction photographs, I realized the rather obvious thing is you can't tell if that building's being assembled or disassembled. So he had sent me this photograph as well. So you can see the yellow expanded foam, which builders use to give the building air tightness, is on the building already. So that's obviously a building that's been deconstructed. And here are the concrete elements of the building stacked up in a car park, ready to be shipped over to the new site in another part of Amsterdam. This is another one of their buildings, which I like the sort of idea. I don't like the end result, but what's really interesting is, as designers, make your buildings as simple as possible. And by that, I mean, reduce the number of components and material types and elements in a building. So here you've just got a steel frame, you've got a timber structural deck, you've got a lift core, and you've got a facade. And that's really all it is. I mean, apparently there are only ever three people on site to make this building, which is obviously, it's all made in a factory off site, prefabricated, and arrives on site. And even the floor system is screwed down so it can be unscrewed. So that's the soundproofing, the subfloor, and then the finishes. And that's the end finished building. This is the bit I don't like, because I'm thinking, how's that building not getting too hot or too cold? What I like is the principle of materials and components arriving on site. Make sure they do more than one job. They're doing a lot of work for you, and then you reduce the amount of stuff going to waste on a project. I prefer this project by CPZ. So this is the original building from the 1970s on the left there was deconstructed and forms this new greenhouse building of theirs. So that cladding system is 50 years old on a brand new building. So I'm going to end with two more slides. Some more good news is we're teaching it as well. And a lot of schools of architecture are teaching adaptive reuse. And I'll do more than two slides, actually. In Brighton, I've got a postgraduate studio called Hyperlocal. And we do resource mapping using Google Maps. So we get our material palette from different types of waste streams that we locate in the area that we're working on. So it's happening for real. Thank you very much. That's me. Done.
Thank you, Duncan. Thank you. Very interesting indeed. Now I would like to open the floor to the audience for question. Please feel free to type on the chat or raise your hand and ask the question yourself, which is always nicer. Alex.
So when I was looking at like all of the precedents and studies I saw, sometimes I saw like you didn't quite like the designs, or sometimes it didn't seem as quote unquote impressive. Does there need to be a trade-off between like reusing materials and like when you're like recycling materials and having like good design or like appealing design, essentially, aesthetics wise?
I would say not, but I wish more and more people did it, so we got more different, diverse attempts at what the language of 21st century architecture, which is building new stuff out of the existing stuff. I want to. There's going to be thousands of different ways of doing it at the end of the day. It's a bit like early days with video with Betamax, and what is the way? Well, there won't be one way of doing, but do you see what I mean? So I think the reason I mentioned that with CPZ is because they do go down this route of very rigorous modular buildings. And I'm just thinking, okay, that's great. You've hardly used any resources in making that building. It's so easy to deconstruct. Well done, well done. But a totally glass facade is how are you keeping that cool in the summer, and how are you keeping it warm in winter? There must be some serious mechanical ventilation and heat recovery systems in there working hard. So, there are other examples which I've got a bit more time for in terms of their future performance as a building. But, I've done it myself with projects, which I don't tend to dwell too much on our own projects when I'm doing this, but we've designed buildings where they're only 2 stories high. So we've used load-bearing masonry stuck together with lime mortar, and we've got sort of solid walls that are 215 mil thick, and then we just bolted insulation on the outside of that, and then a zinc or timber on the outside of that, and it's really simple. It's a similar idea to CPZ's, but we're coming up with thermal mass on the inside, and all external openings on the south and east and west have got shading for some degree. That doesn't seem to be figuring much in CPZ's thoughts, but I could have shown you more work by the Lendiger group, where they are beginning to really test the aesthetics of reuse. And I think there's some more examples in my book of people doing that. And I think that's a real exciting opportunity, because with adaptive reuse, what we're doing, if we're going to make buildings climate resilient, we've got to do more than insulate them. We've got to shade them for the excessive temperatures in the summer or even the spring now and autumn. So, the aesthetics of the architecture response to that is going to be really interesting. And it's barely touched at.
We have a couple of questions. The first one is from Aditya, who left the meeting because I don't know commitment, but said I will listen to the answer on the recording. Do you want to read it yourself, or would you like me to read?
Oh, me? Well, hi, everyone.
Is recycle really the first step? The reason I ask is because I work on an interior design project for a circular fit out, and we prioritize reuse on site, then reuse off site, then repurposing, repair, and then take back schemes before recycling. When we add items to discard and told our contractor, they said they will recycle it, but we didn't know how, where, or in what it gets recycled. So it was hard for us to say that our discarded produce will be recycled. It's the personal choice for this belief too, since there was an article about how someone put a detection service in their plastic bottle and put it into recycling bin, but they realized that the bottle then traveled across.
Yeah. Woo! Okay, that's your dissertation. Yeah, right. This is recorded. Here's my answer. At the moment, if you want to ensure that, like we have on some projects, ensure that secondhand material is being reused. But by the way, prioritize reuse over recycling. Recycling means, so getting the language correct, recycling means that you are melting, shredding, and reprocessing a material so that it's almost new again. So, and in case of plastic, of course, it is new again. So I'm not the biggest fan of recycling. I'm much more into the reuse and reprocess. So when we're looking at creating plaster out of chalk and clay on site, we are sort of recycling because there's a carbon footprint associated with the equipment required to reprocess that material. So that's sort of recycling. But reuse is really the holy grail, where you can just get a window from, take it off one building and put it on another. And that's what really interests me. Understanding whether contractors are really going to do it, etc., etc. If it's on the site already and you're hovering over it and you can see, and you've done a measured survey and a deep audit, deconstruction audit, whatever, it's there. So it's part of the project. But if it's more like just material flows into skips, etc., yeah, that's very informal and difficult to track. And that's one of the challenges. But that's also why we need the legislation to encourage reuse over recycling and definitely discourage throwing away. And the more skips that take stuff to landfill and incineration, there should be higher charges on that, which will encourage people to keep stuff on site and adapt what's already there. But one thing I would say at the end is interior architects and interior designers have been doing this stuff for years, and we often work quite a lot with the people in those practices because it's more like instinctive. So for them, the Pedagogies of Reuse book I co-edited with the head of interior architecture at the RCA, Professor Graham Brooker, and I often find that I've got a lot in common with interior architects and interior designers.
The next question is from Ananya. Ananya, would you like to ask a question yourself? Okay, we're going to ask the question. Ananya is currently in a final year at the Master of Queens. I'm working on a readapted reuse of a farmyard and an extension. Do you think it's possible to design for the construction with historic buildings?
Yeah, and we do it all the time. So historic buildings are really a lot more straightforward because buildings from the 19th century backwards, 18th, 17th, 16th, they are often timber frames that are pegged together without more timber, or they're screwed together or nailed together. And where there's masonry, whether it's brickwork or stone or tiles, well, let's stick with brickwork and stone, they're sort of stuck together with lime-based mortars. So that lime allows the elements, the brick elements or stone elements, to be taken apart really easily. The interiors are finished with lime plasters, the external with lime renders. One of the guys that works with us a lot with the plaster, etc., we talked about, he's a building conservation expert. So he understands those technologies I just mentioned, the construction technologies of historic buildings. And so we can learn, those buildings are all material stores for future buildings. So for me, it's actually easier to do. I mean, if you've got a 1960s through to a sort of 1990s or noughties building, they are sometimes very challenging to deconstruct because they're sort of plastic type materials. And by that, I mean in situ cast concrete, or whether that's for the frame or the walls or whatever. I mean, if you're pouring concrete on site, the most you can, well, what I want people to do is really keep it in sight and think of concrete frames and concrete decks as the sort of infrastructure that you're designing around. Don't crush them up, because crushed up concrete has a high carbon footprint, even though sometimes we have to do it, like with the burnt out house I showed. But I think with historic buildings, yeah, it's a lot more straightforward. They're designed as material banks to be adapted.
I mean, what I would say, it's nice to see. I don't call them students. I call them the future architect, future designer are into circular economy, into retrofitting, reuse, very strongly. And I'm very glad to see that you were discussing about Brighton, this master that really deal with existing building. How do we
We're doing it throughout the school. The undergraduate school students have been working on adaptive reuse projects, and as the masters have. So yeah, no, it's really interesting. They share data, because I quickly showed you the Google map, which you can. I didn't know this. I mean, this is the other thing. Working with young people, they know the technologies they can and understandings they can bring to projects are great. But you can sort of grab a live Google map of an area, and you obviously you can put different layers of information on it and find out where local factories are. Because if you understand what's produced in the factory, you can probably speculate or even check on Google Earth what the waste flows are out of these factories, and it could be really useful stuff. So it's starting to sort of join together these these different flows that don't normally talk to each other. But yeah, we've got an ongoing map, and the reason I dwelt on it then is because our master's students had a really good go at it, and then we passed it down to the undergraduate students to have another go at it and add more and more layers of information. So we use the resource map as a collective resource map. We're not saying, oh, I've got the information, you can't have it. It's an open source resource map. And yeah, well, I mean, we can do that one day for the whole of the UK.
Yeah, we did it for the opposite. I introduced teaching adaptive reuse 7 years ago, and undergrad, and then now the undergrad, the proper module, which is Design Studio, adaptive reuse and retrofit, because I always think they need to understand, because they are the one who will inform other people. And I feel that these are impact on the final design, the knowledge they will bring in the industry, because students are the future. And it's this critical mass already on board on understanding the potential of the existing built environment. And it's nice to see that people are planning to this.
Yeah.
We have other question here.
I have a question.
Oh, please, let's see.
So what is your take on the scaling aspects of this circular economy perspective? Because say we have all the projects that you showed, which are, say, 4 floors or like in a certain scale, right? If you were to go vertically, like in a tower or like a big master plan, what's the kind of circularity that you think would be a possibility?
Really good question. I mean, a lot of the bigger buildings are really modular, so it's lots of the same sort of, even something like the Shard, it's the same, it's thousands of the same sort of glazed panels. So I mean, the Shard's actually a good example of a building that could be deconstructed. I often point to the Shard and say, I mean, it's sort of mad glass on all elevations, because as with the CPZ building, you're going to freeze or fry unless you throw a lot of gear at it. But that building's got a concrete core, and it's got a lot of concrete in the ground because of the really complex ground conditions with lots of different railway lines running through the site. But it is then a steel frame bolted together with prefabricated, precast concrete planks dropped in to form the floor. So that's a material bank for future buildings. So well done to it. But I do know local authorities, when we were working for the London Borough of Newham on their retrofit, we were looking at retrofitting to totally different building types. It was part of a larger project, and one of the feasibility studies was looking at how to turn the Royal Albert Docks into a remanufactory. So this is what we, with the physical infrastructure, I didn't dwell on it, but actually my master's students this year are designing remanufactories. So this is a place that receives secondhand construction material, cleans it up, gives it a warranty, and then sends it back out into the supply chain. And you can imagine with the Royal Albert Docks, which is near London City Airport, it's right near a lot of London. So if a lot of deconstructed building elements were going down to the docks to be reprocessed and crucially given the warranty before it was put out into the supply chain, that is what we need. And I don't think we're that far away from it. There's circular economy projects out there in the UK that are sponsored by Amazon. So I think the digital platforms are probably already there. So there's sort of emerging and smaller digital platforms like the Excess Materials Exchange, who came over from the Netherlands. They've been working in Enfield in London, and they did a little digital platform. Which what I'm talking about are platforms where you can go to it and purchase secondhand construction materials. And these platforms seem to come up and then die. But I noticed they put it out as a public note that the Excess Materials Exchange have just received $5 million of funding to develop their platform in the UK. So I know that a lot of the Dutch innovators are looking at the UK thinking it's going to happen here because of the circular economy plan we're about to have, because of the net zero carbon building standard, because there's a lot of talk about the circular economy, and there's a lot of cities and towns, as I said, have got circular economy route maps, and if we just get the right legislation in the next year or so, that digital and physical infrastructure will just be there, because we might not have to build any of it. It would just be adapting the warehouses to create these places that receive secondhand stuff. The one thing I think they do need, though, there's a sort of research and development element of it all that needs to be in it. So when these materials are coming, there's a lot of stuff we don't know about. And also when you deconstruct a building, however deconstructible it is, there are always waste flows. And those waste flows, that's where you use recycling. You recycle those waste flows into other construction products. And that's where we need a lot of R&D, I think.
Yeah. And I had another sort of question. So when we say we design for longevity versus when we want to design for disassembly,
yeah.
With disassembly, you're adding more bits to your building. Like, let's say in the embodied carbon reduction roadmap, the first thing is build less, which is use lesser material. But if you want to design for disassembly, you're adding bolts, you're adding more joinery details to make it a jigsaw-like disassemblable thing. So
I'd say maybe you're not. It depends. It depends. I mean, you have to get into the specific design of the specific building part, but because what I was advocating earlier is that you, as a designer, you should try and simplify the construction systems to have less elements. And then if you marry that to the ambition of not sticking things together, it depends what building you're talking about. If you're talking about, so then we get into a really long discussion. So, but I think it really depends. I don't think necessarily designing for disassembly means adding more complexity. Because if you think about passive house design, at the moment, the way we achieve those levels is with layers of stuff, lots of layers in a wall. And they are actually all opportunities for something to fail. And if you reduce that from, say, the number of layers through a passive house wall is probably about 8 or 9 layers. If you're thinking about, internal finishes, vapor control layers, battens, cross, but all the different layers. And if you look at reducing that, and if we talk about a 2 or 3 story building, it can be a load bearing building. So if it's a masonry building, then just apply that's in compression, then just apply if you're using a lime mortar instead of a cement based one. I think that's a reduced complexity in my point of view. What you don't want to do is make it overcomplicated. But I would actually say I'd answer the first part of your question, which was about designing buildings that are really have got a long life, that are robust and durable. That's okay, but it's not much of an argument if that building in 5 years' time, which is made of stone and granite or whatever it is, and is really tough, is in the way of a road or a park or something and has to be demolished. So I think we got to prioritize allowing our buildings to be demountable, because what looks like a permanent idea, a really good idea this decade, next decade might be in the way of a better idea.
Yeah. Okay, I see what you mean.
I mean, sometimes it's well about making a build a bit loose.
Sorry, you broke up.
Designing a build which is a bit loose sometimes.
Yes. Oh, I mean, I have said out loud, I'd rather a building that was a material store for the future and a bit leaky than something performing at passive house standards that was just all doing that by being stuck together by expanded foam, etc., which in the UK is often how they achieve that. I know a really good passive house designers who know how to detail their buildings and say you don't need that, but it often happens when you're not specifying that. The way air tightness is achieved is by using those expanded foams at the crucial junctions. And it's when you're trying to deconstruct a building, when you come across that foam stuff, that is, I mean, rotors say that's one of their, but that and asbestos are their enemies.
Definitely. Do you any other question? Otherwise, I will pass back to Dipsy. I think we don't have any other. So from my point of view, I would like to say thank you everyone to attending today. And thank you for Duncan, first of all, to accepting our invitation and discussing about the importance of circular economy, reuse, and deconstruct. So because I think the most important thing, it was like thinking about deconstruction at the design stage. Our next meeting, let me open the last of this series. I will share with you is it's quite far. We have a bit of a gap now. And the next one will be on the 24th of April, Regenerative Design Mindset with David Cheshire from ICOM. Usual Zoom link registration, usual time 7 to 9, and still we will have like first the lecture and then time for the question and answer. Adipti.
I think there's one last question.
Oh, yes. We have a question now.
Yeah. Do you think the Passive House Plus or BREEAM Outstanding certificates are more important than designing for circular economy from a client's perspective?
I think you need to do the whole life carbon assessment of a project. And so it's the whole life carbon footprint being as small as possible is the big deal. But what we don't have at the moment, even with when you're doing LCA calculations, they don't really allow for materials being deconstructed and reused at the end of life. So they expect, if you're working with timber, they assume it's going to be burnt. So I think at the moment we don't quite have the metrics to explain what good looks like from a circular economy point of view, to be really honest. So from my point of view, you need to do both. Ideally, it performs to passive house standards. So that means, for me, that means virtually no energy input over so you're really dealing with operational carbon, really reducing that down to not a lot. And then embodied carbon means that the whole life carbon strategy of the building assumes that one day those materials will be reused again and again. So that embodied carbon is captured, and you don't have a sort of carbon burp at the end of the building's life where the building is destroyed.
Yeah.
What I think the challenge is don't go down this sort of just one issue route. I think it's more complex than that. And I would admit that, like I said, we don't have the metrics to explain what good looks like with the circular economy at the moment, because there's a degree of trust as well. But I think if you've got BIM models and material passports, we haven't mentioned material passports. If you've got the data on what the building is that's been constructed, and you can hang on to that data. And I was talking at a conference a couple of days ago about the idea of a centralized public open source database on all buildings, like the digital twin of a building. It would show you what you've got there in potential embodied carbon, as well as its operational carbon performance figures. You would know that if you threw that building away at the end of its life, there'd be this carbon burp, which might be unacceptable.
Yeah.
But if you deconstructed it and reused it, you're redistributing that embodied carbon, that lot carbon to other projects.
Yeah. I did also see this company called Circuland. I think it's a software development company.
Right.
Where they're doing this thing where they're putting small NFC tags on each and every element of a building.
Yeah.
And if you, at the end of life, like sort of scan a window or a table or a chair or a flooring, you know which company gave it to you. So you can either send it back to them or you can disassemble it.
There's quite a lot of, I mean, what's interesting at the moment, there's a lot of sort of homespun people having a go at the different parts of a circular economy, and they need to add up to something that's quite healthy for the circular economy. So there's different goes at material passports. There's the Madasta Foundation who are out there doing a lot of work, but they want you to, they want to own the information and then charge you for access to it. But there are architects out there who are doing their own material passports. There are clients out there, larger clients who, I'm talking about the Grosvenor Estate and other people who, they've got empty buildings, so they're deconstructing elements of one building and storing them in another building they own. So there are people that surprise you actually having a go at this at the moment. But in a way, it's informal practice. So what we need is the legislation and the sort of formal infrastructure to support this, because at the moment there's a lot of people having a sort of informal go at it.
Yeah, that's true. Okay. I'm gonna share my screen again to ask another last question to everyone. So see my screen. So yeah. So if you can all sort of scan the QR code again and let us know what were your key takeaways from this session and what you learned from it, that would be great. Is the link working for everyone?
I've tried twice and mine hasn't come up.
I shared the link anyway in the chat as well.
Mine's still live on my phone. I thought it was working. I've got the question.
Yeah, you enter a word to pop it up.
Be aware of my knowledge. Jeez. Sorry, I'm reading that wrong.
Think about the future before starting. It is possible. That's a positive note. People are doing it now.
I love Duncan's knowledge and appreciation of the.
Look at what other countries
Alan Duncan's knowledge is expensive. That's what I'm reading. I'd agree with that.
Learn more material and chemistry behind it. That's interesting. That's great, everyone. Thank you so much for joining us. And thank you for all of you who have been also part of other sessions previously. And I hope it's given a good overview. And please join us in the last session on the 24th of April with David Chisher. And thank you and good night.
Thank you for inviting me. I really enjoyed it. Thank you,
Thank you,
Louise and
Duncan.
Dipsy. Thank you very much.
Thank
Thank
you.
you, Duncan, and everyone. Thank you for making it today. I'm sure that will be an impact on your future design.